many of you would be knowing as to really what an interpreter is. What is an interpreter? Well, let me tell you this way, that in the previous session, I had told you the difference between an assembler and a compiler. Well, both of these I would be calling them as system softwares, and what they really do is to take in input in one form and produce the output in another form. For example, an assembler would take the input of a program in the assembly level language and was producing the output in the machine level language, whereas a compiler would take the input in the high level language and was producing the output in the machine level. This is what you had learnt in the previous session. But then what really is the difference between an interpreter and a compiler? Well, you already know as to what a compiler does, and what really does an interpreter do? Well, an interpreter is going to take the input in the high level language form and it's going to be producing the output in the machine level. Well, the moment I say that, I am sure the next question that you would have at the back of your mind is, what really is the difference between them? Because both of them seem to take the input in the high level and produce the output in the machine level. So what really is the difference between the terms compilers and interpreters? And adding to that is the terms present here in the architecture. Well, there is something called as compilation. There is also something called as the interpretation. So does Java really do both of these? Well, you could be having a lot of such doubts, but then if really such doubts has to be clear, then firstly we have to progress and understand really the difference between compilation and interpretation. So let me proceed. Well, even before I tell you the difference, let me clarify to you that whatever difference I am stating to you happens to be the generic difference between the two processes, interpretation and compilation. As of now, I have still not spoken anything about the Java architecture and how really compilation and interpretation gel well and have made Java whatever it is today. I would definitely tell you as to what the role of compilation and interpretation process is in case of the JVM. But first, what we really have to understand is the generic difference between the two terms. So what really is the difference between a compiler and an interpreter? On the face of it, it appears that a compiler is taking the input in the high level form and is producing the output in the machine level, and the same is what is being visible even in case of the interpreter. So if you really have to understand the difference, then in case of the compiler, you would have a code called the source code, which would contain the program in high level, and then you happen to give it to a compiler which is going to produce the code in machine level, and then there is something going to be the execution phase in which we would be giving the machine code to the machine and getting it executed. So very clearly there would be two distinct phases in this. One, the compilation phase, and the second, the execution phase. But then it's not the same in case of interpretation. In case of interpretation, say supposing you have a code which is in high level, and if it's given to the interpreter, it not only converts it to the machine level, it also definitely executes the code as well. And only after that first line is executed that the next line is considered for conversion to machine level and execution. In other words, here it is converting and executing, converting and executing. In other words, that is what is called as interpreting. Each time it is converting and executing the code. But then here, you know, all of the code which was in high level went into the compiler and we got all of that code in machine level. And then in the execution phase, it is the machine code which we happen to give to the machine and get it executed. So two distinct phases here. One, the compilation phase, and the other, the execution phase. But then here you can notice it's hard to distinguish between the execution and the compilation because both of it is what is being done by the interpreter, and that is what is actually called as interpretation. Well, there are some other differences as well between them which I would wish to share with you. In terms of the speed of execution, compilation is faster when compared to interpretation, and obviously compilation would be faster. Look at this. what we have just before execution is the machine code. All that you really have to do during execution is to give the machine code to the machine, get executed and get the output. Obviously, it would be fast because in this case, during execution, you are actually converting the high-level language code to the machine code and then executing it. In fact, this process of converting and executing is what we call in single term as interpretation. So, interpretation basically means that you are converting and executing, which obviously is going to be pretty slow. In other words, obviously, programs which are compiled and executed are going to execute faster when compared to programs which are interpreted and executed. So that happens to be one of the difference between them, though both of them actually tend to execute the high-level language code. The way this executes high-level language code is different from the way this executes the high-level language code. And if you'll ask, are there any other differences? Well, it's in terms of the way they actually show you the errors. Well, in this case, as you can notice, the entire program is compiled at once, or in other words, is converted at once, and just in case there are errors, all the errors are going to be displayed to you at once. That's because all the lines have been converted, right? So all the errors would be displayed to you at once. But in this case, you cannot expect all the errors to be displayed at once. After all, it is a single line which is taken and then converted and executed, and obviously during the conversion to machine level or during the execution, basically during interpretation, if there is any mistake that is encountered, then the mistake which is there on that line is what is the error that the interpreter can actually show to you. It cannot show all of the errors that are there in your code because your code is still not completely taken up by the interpreter, because it's a line by line process that happens in interpretation. In other words, in as far as the errors are concerned, in this case, you would get all the errors at once, but in this case, you would definitely get the errors line by line. What are the other differences? Let me tell you. Another difference between them is that in this case, you may not need the source file at all once you have got the executable code and if you really want to repeatedly execute the program. What I mean to say is that, say supposing you have the source code, you have given it to the compiler, and you know the compiler is going to produce the machine level language code and is going to keep it in a file, maybe the executable file, and say after that you are going to take off the source file. Absolutely no issues. Once you have the executable file with you, definitely you can give it to the machine and execute the program any number of times that you would wish to execute. In other words, in this case, the source code is not required to execute the program, provided using the source code you have already obtained the executable code, and obviously all of the executable code, if it is there in a file called the executable file, then the machine can execute it and produce the output even if the source code is actually not available. But things don't work that way in this case. In this case, you have to have the source file if you really have to interpret. That's because the machine code is actually not stored anywhere. You know that when the line gets into the interpreter, it's going to be converted to the machine level and then immediately executed. Obviously, the machine code is not stored anywhere, and hence, if in case I take off the source code, then how would you really execute it? Well, in this case, even though I took off the source code, I had something called as the executable code which has the machine level language. But in this case, there is just the source code, and if I would take it off, obviously there is no way that I would be able to execute the program. In other words, what I would wish to say you is that in case of compilers, even if the source code is not there, provided you have the executable code, it is still sufficient for you to execute the program any number of times that you would wish to execute. But in this case, you always have to have the source code if you really have to have a look at the output. I'm sure you've been able to understand this. But then, are there any other differences? Let me tell you. Programs that are coded in languages such as C and C++ for execution follow this approach, that is the compilation approach, whereas the code coded in PHP, Perl, Ruby actually make use of the interpretation approach to execute. Anyway, this happens to be the difference between compilation and interpretation. Nevertheless, if you'll ask me what is the story in case of Java, well, this is the architecture, and you can notice both the terms there, compilation as well as interpretation. So what it all really means is what I had to communicate to you, and you know that in this session I actually had to explain Java's architecture for you. But then just imagine if you as a learner, as a beginner, could have understood Java's architecture at one go in the second lecture itself, then let me tell you, there is absolutely no need for you to undergo this course. If you have to understand all of the features of Java, then you need to understand Java's architecture, basically the way JVM has been designed, and definitely it's going to be a lengthy process. I will have to explain component after component in this and then gradually merge all of this and then tell you how really the JVM functions. Definitely in this session, I'm sure you've been able to understand a host of concepts, though you've not been able to understand as to what really a JVM is. In fact, what really is a VM, a virtual machine, is also a doubt which is possibly bothering you. In my next session, you would definitely get to know everything that you have to know about JVM and would feel a lot confident and would also agree with the fact that Java indeed has remained as the #1 programming language, basically because of its architecture. See you in the next session.